Okay, question 3. Right, before I start question 3, I just want to go back to question 2 because I realised that I missed something out on here. It happened. I missed this bit, and that is really common for people to do. I wondered why that question was worth 3 marks, and this is why. It says give it to 2 significant figures, and you can see my answer is 1, 2, 3 figures. So, 1, 2, draw a line. We've got our 2, that doesn't round it up, so therefore our answer is 58.0. Okay, so this needs to change to 58. That is our answer. 58 coulombs. Alright, now we'll start question 3. Question 3, calculate the total resistance of the 2 resistors in the circuit. We looked at that before. You just have to know whether these are in series or in parallel. And we can see here that the current always goes from positive to negative. So it's going to go around the current, it's going to go around here, it's going to go through that ammeter. It's telling us the current there is 0.3 amps. It's going to go down there, it's going to go through here, it's going to go through that first resistor, then it's going to go through that resistor, then it's going to go down there, then it's going to keep going, there, 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 and then back to our negative terminal, and then it's going to pick up some more charge and carry on flowing around. A lot of people think that the current might go down here as well. It doesn't. The current doesn't go that way. That's just a voltmeter. The voltmeter is just looking at the difference in energy between here and here. It's not a path for the current. So this is a series circuit. So in a series, remember, to get resistance, we add resistance, because the current has to go through both resistors. So we have 9 plus 6. You can get the calculator out if you want. I would suggest you do, even if it is a really standard answer like that, because you just want to make sure, don't leave anything a chance in our exam. It gives us 15 ohms. Calculate the reading of the voltmeter and show clearly how you work out your answer. So we have to show off things. So we're going to use FIFA. Okay, so FIFA, the first we want to find a formula. Now, this is a bit of a tricky question because we have to think about what we've got. So we want a voltmeter. The voltmeter works out potential difference. So PD, voltage, or potential difference. It's the same thing. It's got 2 different names. Potential difference and voltage are the same. So we're trying to find voltage. So we want a formula that's got a V in it for voltage, or in words, potential difference. We have been given a current. So here, that's a current. And we have got a resistance from our last question here, which is the total resistance. So we've got a current, and we have got a resistance. And we're trying to find out the voltmeter reading, so that's potential difference. All right, let's go to our data sheet and let's see if we can find a formula that has current, resistance, and potential difference in it. Rub that one out because we don't need that one anymore. Current, resistance, and potential difference. So as soon as you see any of those things, there's current here, but that's got charge in it, so that's no good. Current here, resistance here, and potential difference there. There we go. V equals I times R. So we use that formula. We can write that down. V equals I times R. V is a potential difference, I is current, and R is resistance. You don't have to remember that. It tells you V equals IR, and it tells you in words what they are here. So, next stage of FIFA is to input our values. V is what we're trying to find, because it wants the voltmeter reading, so we leave that as V. The I is our current, and we're told here that the current is 0.3 amps. Found that on the ammeter. And we're going to times that by the total resistance in the circuit, because all of the current had to go through both resistors, which is 15. So we don't need to rearrange. We can go straight into our answer. Let's see if I don't it's not asking us for significant figures. It's only worth 2 marks, so it would make sense to pick the formula and then to just work it out. So grab our calculator again. 0.3 times by 15. 0.3 times by 15, oh, that's 12, times by 15 is 4.5. Just check it one more time. 0.3 times by 15 is 4.5. So 4.5. You don't always have to use all of FIFA, by the way. I've just used the F and the I there. It's just a guide. It's just to help you remember the different steps in your process. All right, this one. Draw a ring around the correct answer in the box to complete the sentence. Replacing one of the resistors with a resistor of higher value will decrease, not change, or increase the reading on the ammeter. So the ammeter is the current. So let's think about this. If we have high resistance, so we make it harder for the current to flow. So if the current's having to move through here, yeah, and we make it high resistance, that's going to make it harder for the current to flow, so there's going to be less of it. So it's going to decrease our current. Think about resistance like this, all right? If that is what our electrons have to go through, and all of a sudden we just squeeze this area, so it's harder for those electrons to get through because they can go all the way through here, but then they have to squeeze through that area. All of a sudden, more resistance, it's harder to get through, so the current actually goes down. So we decrease in current. And okay. Yep. Right, part B. The voltmeter in the circuit is replaced with an oscilloscope. Oscilloscope is something that just shows wave. Just shows a wave pattern. I like that one. It shows a wave pattern. Which of the diagrams, X, Y, or Z, shows the trace that would be seen on the oscilloscope? Write your answer X, Y, Z in the box. So we can cross out Z because that's got nothing to do with electricity. With electricity, and what you need to know is that mains electricity is what we call AC. What that means is that it alternates. So it goes positive, negative, positive, negative, positive, negative, positive, negative. So that one would be mains electricity. Anything that comes from a battery is what we call DC, and that means that it only has a positive value. So if this was a graph like that, and that was the same with that here. If there were your positive values and there were your negative values, and that was 0, positive, 0, negative, you can see that the DC just stays in the positive, just slightly positive, whereas the AC goes backwards and forwards because the current goes backwards and forwards. So we can look at our circuit, we can see that these here are batteries, so it's going to be direct current. So our answer is going to be Y. And the reason why is that a battery provides direct current. Okay, and to question 3.